Have you ever listened to a song and wondered how one single instrument, like a guitar, can create so many different sounds? It can play a low, deep note one moment and a high, sharp note the next. How does it do that? How does a musician choose which sound to make? And how does the instrument know what to do? The answer is simpler than you think, and it's all about a little bit of physics. Let's start with a guitar. It has 6 strings and a long neck with metal bars called frets. When a musician plucks a string, it makes a sound. But if they press their finger down on a fret, the sound changes. If they pluck a different string, the sound is different again. It seems like magic, but it isn't. The musician is simply telling the string how it should behave. They are solving a tiny problem with every note they play. How to create the exact right sound. The real question isn't just about the guitar. It's about how any instrument, from a piano to a flute to a drum, can create an entire range of musical notes. The secret to all sound is one simple action: vibration. When you pluck a guitar string, it shakes back and forth very, very fast. This shaking is called a vibration. You can even see it if you watch a string closely in slow motion. That vibration pushes the air around it, creating invisible waves that travel to your ear. We call these sound waves. Your brain interprets these waves as sound. But why are some sounds high and some sounds low? It all depends on how fast the vibration is. Scientists measure this speed using a term called frequency. A slow vibration has a low frequency. This creates a low-pitched sound, like the rumble of thunder. A fast vibration has a high frequency. This creates a high-pitched sound, like a bird's chirp. So when a musician wants to change the note, all they are really doing is changing the speed of the vibration. Let's go back to our guitar. When a guitarist presses their finger on a fret, they are shortening the part of the string that can vibrate. A shorter string vibrates faster. Faster vibration means a higher frequency, which means a higher note. When they play the string open, without pressing any frets, the whole string vibrates. It's at its longest, so it vibrates slowly and produces its lowest note. There's another way to change the pitch: tension. The tuning pegs at the top of the guitar tighten or loosen the strings. A tighter string vibrates faster, creating a higher pitch. This is how musicians make sure their instrument is in tune. And finally, there's thickness. You might notice that the guitar strings are different sizes. Thicker, heavier strings vibrate more slowly than thinner strings. That's why they are used for the deep, low notes. This exact same idea works for almost every other instrument. Think about a piano. Inside a piano, there are dozens of strings. The strings for the high notes are short and thin, while the strings for the low notes are very long and thick. What about an instrument with no strings, like a flute or a recorder? You blow air into it to make a sound. When you blow, you are making a column of air inside the instrument vibrate. By covering different holes, you change the length of that air column. A shorter column of air vibrates faster, creating a higher note. A longer air column vibrates slower, creating a lower note. Even drums work this way. A big, wide drum has a large surface that vibrates slowly, making a deep boom. A small, tight drum has a smaller surface that vibrates very quickly, making a sharp, high-pitched tap. So the hidden problem that all instrument makers have to solve is simple. How do you build something that gives you control over vibration? The solution is always found in changing one of 3 things: the object's length, its tension, or its size and weight. Every note from every instrument in the world, from a violin to a tuba, is just a beautiful, controlled vibration. By learning to control the length, tightness, and thickness of strings, air, or surfaces, we learned how to make music. The patterns of math and the laws of physics are the hidden sheet music that all instruments follow. So the next time you hear a melody, remember you are just listening to the simple science of things that shake.